today for coming to this lecture. Today we start the new chapter, which is I'm going to share it in the screen. The slides. These slides are already uploaded in my UVT platform. Okay, so you can find it in my UVT platform. So let me. So today is interdependence and gains from trade. Okay, I think you remember in the previous lecture we have talked about many principles of economics, and the principle number 5 is trade can make everyone better off. Okay, we spoke about this. Trade can make everybody better off. So in this, so rather than being self-sufficient, people can specialize in producing one good or service in exchange for its for other goods. So specialization in the production of something in a good service and the trade will make everyone better off. In this class, in this session, we will explain how trade is able to make everyone better off. So we will demonstrate this principle. Okay? So this is the objective or the subject of this lecture is to confirm this principle number 5, that trade is good for everyone, for individuals and for nations. Okay? So in this chapter, we'll answer several questions. The first one is, why do people and nations choose to be interdependent? By interdependent means one needs the other. One needs the other means we make trade. Okay? How can trade make everyone better off? So as I said, we will demonstrate the principle number 5 and why nations trade. Why nations trade. Why people trade, individuals trade, and why nations trade. When we talk about individuals trade, we talk about simple domestic trade. When we talk about nations, when we talk about nations, so it's about international trade. Okay? So here we will see many new concepts important for in trade economics, and these concepts are mainly these two ones, which are the absolute advantage, okay, and more importantly, the comparative advantage. So this is the key word. Just the key word in this chapter. When we talk about trade, whether domestic between individuals or between nations, okay? Okay, when we talk about nations, trade, whether domestic or international, we always okay, talk about this important concept that is a comparative advantage. Okay, comparative. So from this word there is more the word comparison. So we are going to compare two things, two countries, two individuals, etc. Okay, so here we start with this nice small image. Let's show the interdependence. Okay, you see this guy, he's using many goods now, he's wearing and using many goods. For example, you see he's using a hair gel that is from Cleveland in the United States. But in the same thing, he's using a cell phone that is produced in Taiwan. Suppose that this guy is an American guy or a Tunisian guy. Okay. So he's using a product, hair gel, that is produced in the United States, not in Tunisia. He's consuming or using a cell phone produced in another country, not his own country, that is Taiwan. He is wearing shirt produced not in his country, but in another country, China. And he's drinking coffee produced also not on his country, but in another country, that is Kenya. So here, especially in our modern times, you see that I think it is the same for you if you look to the things you are wearing and using every day. You will see many goods or services that you are consuming or using every day. They are not produced, not all are produced in Tunisia. Many are produced or provided from other countries. Okay, this shows how interdependent individuals and nations. It was like this since the beginning of time, and especially now, interdependence is more and more important. Why? Because now international trade is more widespread between nations than before. Okay, so every day you rely on many people from around the world, most of whom you've never met, to provide you with the goods and services you enjoy. Okay, this guy is smiling. Okay, so he's enjoying this using these goods and services. So we can understand here how individuals and how nations have become better off. And we will just demonstrate that. Okay. Okay. So here in this chapter, we are going to work on a small model, as I explained it in the previous lecture. We economists work on models, okay, to explain economics to the world. Okay. So in this lecture, we are working on a small model based on this small model example. Okay. So let's suppose in a model there are only two countries. Okay, these two, the US and Japan. So as I said in the previous lecture, we work on model which is a simplification of the reality, of a complex reality. Of course, in the world, there are more than 200 countries, so it's very difficult to work on 200 countries. So we make assumptions about the world. And these assumptions are aiming, like this one, two countries, are aiming to simplify the world, to simplify the reality. Okay, this simplification will help us construct a model to understand and to understand how things are done or are working or related in economics. Okay, but this assumption should not should give us results and lessons that are true for the real world or can be confirmed by the real world. Okay, so here we make the first assumption that there are only two countries, the US and Japan. Okay, and we suppose that we assume there are only two goods, computers and wheat. This is another assumption to simplify our world. Okay, in the real world there are many goods and services, millions and millions of goods and services, but here we assume there are only two goods. This is another assumption. Okay. The third assumption is that we assume that there are only one resource, that is labor measured in hours of work. Okay, of course, in the real world there are other resources, capital, land, technology, etc. Okay, these are other resources used in the production of goods and services. But here, to simplify things, we assume that there is only one resource, that is work, labor. So I hope you get the point about models and assumptions. Okay, economists use a lot of models, and these models are constructed from assumptions. So we will look at how much of both goods each country produces and consumes. In the case if there is no trade, and we will see how much these two countries consume and produce where there is trade between them. Okay, we will see two situations, consumption and production, where there is no trade between US and Japan, and we will see the amount, the quantity produced and the quantities consumed when there is possible, when the trade between them is possible. Okay. We first start by drawing the production possibilities frontier that we have seen for each country that we have seen in the last lecture. I hope you remember it. The production possibility frontier, which is PPF, it tells how much a country can produce, how many the combinations of goods. So it's a curve, actually, it is a curve that represents the combinations of goods that a country can produce, okay, with the resources that this country has, okay? So let's draw the curve of the US, production possibility frontier of the US. Start with the US. So the US has, we said, labor resources of 50,000 hours of labor. Okay, the number of workers in the US can work 50,000 hours per month. Okay, this is the resources. You have a number of workers that are able to work, suppose 8 hours a day, okay, each worker, and considering weekends and etc., etc. The available number of hours or working hours available for the US that can be used to produce goods and services is equal to 250,000. So this is the available resource for production per month. Okay? So we have two goods in this world. This country can produce whether computers or wheat. Okay? So here, the US will have to allocate some workers for wheat, for the production of wheat, for farming wheat, farmers, and will allocate other workers, the remaining workers, for computers. Okay. We know that producing one computer requires 100 hours of labor. In the US, producing one computer requires 100 hours of labor. And in the US, producing 1 ton of wheat requires 10 hours of labor. So the US needs 100 hours of labor to produce one computer, and 10 hours of labor to produce 1 ton of wheat. Okay? And we have, the US has 50,000 hours of labor. Okay, we can just do the calculations. It is possible to, so there are infinite number of possible allocations, okay? And each possible allocation of this hours of labor will give the US combinations of wheat and computer. Okay, so if the US put all its available resources of labor, 50,000 works, tell them, okay, you produce only computers. I don't need wheat. Look to this screen, please. So 50,000 all hours, all for computers. Okay. This means if one computer requires 100 hours of labor, so the number of computer produced will equal to 50,000 over 100, which give us how many? 500. يعطيك الصحة. 500 computers. Okay. If the 50,000 go to wheat farming, then number of tons of wheat, how much it will be? شكون يقول wheat produced. How much? 50,000 over
10.
Over 10, yes. So
5,000.
5,000 tons of wheat. Then, suppose now this combination, the US decide, okay, 30,000 hours for computers and the remaining 20,000 hours for wheat. What would be the combination? So in the first case, if you use the combination will be how many? 500 computer, 0
wheat.
يعطيك الصحة 0 ton of wheat. Okay. In the second case, second situation,
5,000 tons of wheat to 0 computers.
يعطيك الصحة 0 computers and 5,000 wheat. This third situation, 3,000 hours for computers. So this means that number of computers will equal to
300.
30,000 over 100, which makes 300. Yes, 300 computers. The number of wheat will equal to how many?
20,000 over 10, 2,000.
يعطيك الصحة 20,000 over 10 will equal to 2,000. Okay, so in this case, we will have, what is the combination here? The combination of produced goods. How many computers will be 300 computers produced and 2,000 tons of wheat produced. Right? I come back to my presentation.
Sir?
Yes?
For example, in an exercise or while deciding upon the combinations, we need, I mean, possibilities. We can choose them or معناها يبدأوا عنا the combinations.
No. The combinations, there are infinite number of combinations. So here, if we continue our exercise we have done for the US, and we join each combinations of produced goods, we get the PPF, the production possibility frontier. Okay. And here, each point in this curve represents a combination of goods and services, of goods, wheat, and computer produced, according to corresponding allocations of resources, that is labor. Okay? So there is infinite possible combinations of this curve. There is infinite combinations of productions of wheat and computer. The question is, if the US, okay, this is the production possibility of frontier of computers and wheat. Okay, production possibility frontier for of computers and wheat. Okay. So if the US, suppose the US cannot trade with Japan, okay, which we call in economics, we call autarky. Autarky means no trade. The country closes its frontier, okay, to trade, to international trade. Okay, suppose the US uses half its labor to produce each of the two goods. If it uses half of its labor to produce each of these goods, معناها 25,000 hours of labor for computers and 25,000 hours of labor for wheat. Okay, it will produce, then this will give a production 250 computers and 2,500 tons of wheat. Okay? So this combination, okay, will represent in the same time production of the US and it will represent also its consumption. Okay, the amount of or the quantity of computers the US produces will be the amount of computers the US consumes. The US citizens will consume. The 2,500 tons of wheat produced by the US will represent, okay, the amount of or the quantity of wheat consumed by the US or by the US citizens. Okay, so production will equal to consumption. Maybe I got the point about the question you asked, I forgot your name, the exercise. Of course, in the exam, for example, if we talk about exam, if we want to ask you how much production of each good will this country will be produced, of course, we will give you the allocation, the possible allocations of resources, okay? And according to these allocations of resources, you calculate the corresponding quantities of goods produced, okay? So there is no other way to do so, okay? So I want to show you that production is equal to consumption when there is autarky, when there is no trade, okay? Let's do the same work for Japan. Derive Japan's PPF, production possibility frontier, using this following information. Now, Japan has 30,000 hours of labor. So the resources of Japan are less than the US. Okay? 30,000 hours of labor available for production of per month. In Japan, the technology is different. Okay? So we need Japan needs to produce one computer 125 hours of labor. Okay, which is larger than the number of hours required to produce a computer in the US. The US needs 100 hours only of labor. Okay. If I could remember. But producing 1 ton of wheat in Japan requires 25 hours of labor. Okay. In the US, how much?
10.
10. Great, you remember. So I trust you. So 10 hours in US for wheat, but in Japan it's 25 hours. So still Japan needs more hours to produce 1 ton of wheat. To produce a computer in Japan is 20, in the US is 100, only 100 hours, but in Japan it needs more hours. So here you see, here in this example, the Japanese technology, whether in computers or in wheat, is less developed than in the US. That is why Japanese use more hours to produce each of these two goods. Okay. The resources in Japan is 30,000. So we should compute a graph, do the same thing. We do the same, as I said, as I showed you in the example. We can trace or draw the BPF of Japan by trying to, for example, find 2 or 3 possible points on this curve and then join them. For example, here, we take this example, this very easy way. If Japan put all its resources for computers, 30,000 hours for computers, 30,000 hours of computer divided by 125 hours per one computer, we get 240 computers. Okay, 240 computers, and because no hours of labor is allocated to wheat, so here there will be zero production of wheat. This is our first point or combination when we allocate all resources to computers. If on the other hand, we Japan put 30,000 hours for only wheat and no labor hours for computers. Okay, so in this case, 30,000 divided by 25 hours needed to produce 1 ton of wheat, we get 1,200 tons of wheat, which is this point B. So A is an extreme point and B is an extreme point. Okay, of course we can find other possible combination, but it's just we need 2 points to make to draw a line, so it's enough to work on only 2 points. Joining this A and B, we get the PPF for Japan. Okay. Here, for example, point C, for example, C, to which it corresponds 100 units of computer and something here, number of tons that is here. Okay. So the same thing, suppose Japan uses half of its labor to produce each good, then it will produce 120 computers and 600 tons of wheat. 120 computers is derived by 120 computers derived by dividing 30,000. Sorry, 1,000.
15,000.
15,000. 15,000 over how much hours for computers?
125.
Yeah, 125. Normally, if we make the calculation, we should find 120 computers. And the 600 is equal to 15,000. 15,000 divided, sorry, my writing is not very good. Divided by how much?
25.
25, yeah, it's, we should get 600 tons of wheat. Suppose now there is how to say central planner or social planner or the government to say directly that in Japan that says, okay, I decide that half of the workers go to farming and the other half of the workers go to computers factories. Okay, so in this case, Japan will produce 120 computers and 600 tons of wheat. How much Japanese will consume then? There is no trade. So if there is no trade, between other countries to export or import things we need or etc., we will produce what we will consume what we will produce. Okay. For example, Tunisia in the 60s until let's say the 80s. Okay, most of the Tunisia was somehow Tunisian government put a lot of barriers for international trade. So we Tunisians could only eat or consume mainly what is produced in Tunisia. Okay, I know you don't know this period, but if you ask maybe your parents, etc., you will see that everybody in Tunisia, for example, if we talk about pasta, for example, everybody in Tunisia could only consume only one brand, one type of pasta that is produced in Tunisia. Okay, because Tunisia couldn't maybe import pasta from other countries like today. Okay, etc. Okay, so here without trade, when there is autarky, what the country produces is what the country consumes. For example, now maybe there are only few countries in the world that are still living in autarky, like North Korea, maybe, or maybe Cuba. I'm not very sure. Okay, these countries are living in autarky, so they don't import many things. Only few things are permitted to be imported from abroad. So these countries they consume. North Koreans consume mainly what they produce. Okay. In many countries, I'm sorry. Yes.
Last time we talked about market trade. وقت اللي بدنا فما أتركي معناتها نجم فما شنو العلاقة معناها فما market trade وسط الأتركي ولا government how it interferes.
Yeah, I see. Also, here when we talk Japan and US, etc., we talk about maybe trade between nations, between countries. So without trade, as I said, consumption here, the US consumers get 250 computers and 200 to 2,500 tons of wheat. Japanese consumer will get 120 computers and 600 tons of wheat. Here, why we show this example in this model of autarky of no trade. Now we will compare the consumption of the autarky consumption with the consumption if there is trade between nations. Okay, we are going to now bear in mind that this is the consumptions of the US and Japan if there is no trade. Okay, now let's compare the consumption to when there is trade between nations. When Japan and the US say, okay, we can trade between each other. Okay, so let's see. So first we need to see how much of each good is produced and traded by the two countries. Okay. So suppose the US produces, okay, now it is possible for the two countries to produce, to trade between each other. Suppose the US want to produce 3,500 tons of wheat, okay? How many computers would the US be able to produce with its remaining labor? This is a question that can be given in the exam. Draw the point representing this combination of computers and wheat on the US DPF. Okay. And this question do, suppose Japan produces 240 computers, how many tons of wheat would Japan be able to produce with its remaining labor, draw this point on Japan's paper. So I will show you how to do these calculations. Okay. So the US will produce wheat, we said, by its given 400 tons of wheat. Okay. Computers. How much? Who can help me to solve this question?
The produced wheat, we multiplied by 10.
What we are looking for? Just let me know what we are going to look for now.
The hours.
Okay. So we are looking for hours, the corresponding hours of labor. Right? It equals
34,000. تعالويت أكها.
3,400, you mean?
The more we multiplied by 10.
Give me the entire formula, because so your friends can understand.
3,400 multiplied by 10.
By 10, because we need 10 hours to produce 1 ton of
yes,
wheat. It gives us 34,000 hours of labor. Okay. Yes.
Then we need to compute the hours.
The remaining hours.
Yeah.
Labor, which is equal to 50,000.
15,000 minus 34,000.
Yeah, which is equal to
16,000.
16. Yes, 16,000.
Then we will compute how many computers produced.
So the remaining will be used for production of computers.
Yes.
So computers will equal to
16,000 over divided by 100.
16,000 hours available for computers divided by 100 hours needed to produce one computer.
One computer.
Which give me how many?
160 computers.
160 computers. يعطيك الصحة. Okay, يعطيك الصحة. Who can do the same for Japan? So in this just to finish. So for the US, in the situation we will have 160 computers and 3,400 tons wheat. Okay. B. Another students can I ask another student to do the same for Japan. I suppose Japan produces 240 computers. 240 computers. 240. How many tons of wheat?
It won't produce any wheat because when we multiply 240 by 125, we get 30,000.
Okay, let's see. Okay, tell me what shall I do? The corresponding, we do the same thing. The corresponding, sorry, the corresponding hours of labor for computers. How much?
140 multiplied by 125.
125, which is equal to
30,000.
30,000. 1,000 hours of labor. The remaining hours of labor will be equal how much?
0.
3,000 available.
Minus 30,000.
Available minus 30,000 used
For
computers. So we get 0 remaining hours. With 0 remaining hours, how many tons of wheat Japan can produce?
0 tons.
0 tons of wheat. So the Japan will have this combination of production, which is how much? 240 computers and 0 tons wheat. Do you agree with Hude and with her calculations?
Yes.
Okay. So here the US production possibility frontier. We said the US will produce 3,400 tons of wheat. And as Noor has said, 160 computers. So her answer is correct. Okay. For Japan, this is the PPF of Japan. So here, this point we call, let's say, call A, is the production represents the combinations of productions for the US. In Japan, producing 240 computers require all of Japan's 30,000 labor hours. So again, and so Japan would produce 0 tons of wheat. Again, Noor was correct in her answer. So Japan will produce here an extreme point. Okay. So now there is exports and imports. There is trade between countries, so there is import and exports. Just to define what do you mean by exports? Exports, it is your freshman, so it's your first year to study economics. I know many words you know, but since you are still it's the first time you study economics, we need to define many words. You are not familiar with them. Exports are goods produced domestically and sold abroad. Okay. To export means to sell domestically produced goods abroad. Okay. Imports are goods produced abroad and sold domestically. Okay, so it's goods purchased abroad. Is the definition clear for you? Okay, so I guess you might easy. So now consumption under trade. In the previous slides, you have seen that without a trade, consumption is equal for each country is equal to its production. Okay. Now let's see what is the consumption if there is trade of each good in each country when there is trade. Suppose the US exports 700 tons of wheat to Japan. We said that Japan is producing 0 wheat, but Japanese need wheat. Okay, so well, obviously, necessarily, they will import it from the US. So they will ask the US, please, we want to buy wheat from you. Okay, so the US exports 700 tons of wheat to Japan, and imports, let's say, imports 110 computers from Japan. So Japan imports 700 tons of wheat and exports 110 computers. So the exports of Japan represents, the US exports represents imports for Japan. And the US imports represent exports for Japan. Okay? So the question is, how much of each good is consumed in the US? Plot this combination on the US PPF. The US consumption of consumption. Let's start with computer consumption. Computer consumption. How we compute this quantity of computer consumption?
The quantity produced by the US plus the quantity imported from Japan.
Okay. Slowly. So the compute, you mean the production quantity? You said quantity
Produced in the US or by
the US. Then
plus the quantity imported from Japan.
Quantity imported from Japan. This gives me
160 plus 110.
how much the US is producing a computer. We said the US 160. 160 plus
110.
110 computers, which gives us how many? 270 computers. No, okay. Now wheat. The same formula. Are you here?
Yes, yes, I'm here, sir.
Okay.
Yes.
And please tell me how much US individuals will consume of wheat.
The quantity produced by US minus the quantity exported by US to Japan.
Quantity produced domestically, okay. Then minus or plus? Minus? Quantity?
Yes, the quantity exported.
Export. The US exports wheat. Okay.
Yes.
Okay. So yes, or wheat consumption. Okay. How much is produced? Do you remember? Let me. The US produces
3,400.
3,400. Plus, minus, sorry.
Minus 700.
700. Which gives me. أصبح. Am I correct?
2,700.
So here, consumption, the US consumption, will be represented by this couple. Computers, how many? 270 computers. And 2,700 tons wheat. Okay. Do you agree? I always forget the P. Do you agree? As to plot how much of each good is consumed in the US. We have just computed that. Plot this combination on the US PPF. Okay, this is our PPF, production possibility frontier. Okay, we say that production is 160 computers and 3,400 wheat. Here, production. Okay, and let's plot the point related to the consumption. Produce plus for each good production plus import minus export. The remaining amount will represent the consumption, which give us 270 computers and 2,700 wheat. This blue line represents consumption. What do you observe?
It's not possible.
It's not? Yes, you are. Don't stop, please. I like your answer. I like your answer. It's not what? Possible. What is not possible? شكون كان ساعة؟ Hint. It is not possible what? What it is not possible?
خاطر الفرونتير تعداها ولا؟
يعكس صح. You are absolutely right. Last time we have said that the production possibility frontier above the frontier is not possible. It must be whether on the frontier, which is an efficient combination of goods produced, or below the frontier, which is also possible but not efficient. The question of Hind, or the remark of Hind, is very, very, very logical. But here, Hind, I say it is possible. Why? Because this point, this is A and this is B. This blue point B does not represent production. It represents consumption.
Yes.
When we talk about consumption, we don't talk. It's not production the same. It's not okay. Here, when there is trade between nations, when there is possible trade between nations, and where it is possible to import and export, okay, the consumption is not always equal to the production. Okay, the point B represents consumption, not production. I agree with you that when you, if B was, if I tell you that B is production, production is not possible. If we say if B is a production, you are right. Production is not possible. Production possibilities can whether be on the line, on the PPF, or below the PPF. Okay. But here we talk about consumption. You see, the production is A. It is possible and it is efficient. Why? Because it is on the line of the PPF. But the B is consumption, is different thing. And here you see when there is trade, unlike the autarky situation, where when there is autarky, where there is no trade, consumption should equal production. Production should equal consumption. Tunisian, if we are Tunisia is in autarky, is living without trade, we will, as a Tunisian, we will eat and consume only what we produce. Okay, because we can't import we can't import from abroad the things we need. Okay, But here, because there is trade between Japan and the US, okay, the consumption is not always equal to the production, because you will consume what we produce, and if you need more, you will just purchase from other countries. Okay, so here you see Americans produce 160 computers, but they need 270 computers. You see? So what did they do? They just purchased the needed 110 computers from the US, from Japan. Okay. So they could then, because they could import the extra number of computers from abroad, they could consume more than what they produce. Okay. The US produce here 3,400 tons of wheat, but what they need or what they consume is only 2,700 tons of wheat. Okay, they are sufficient with 2,700. So the remaining quantity of wheat is exported to Japan to get in exchange computers. So they trade wheat for computers. And here you see the consumption of computers is higher than what they produce. So what we can say that now the US consumers are happier with trade than without trade. Why? Because now US consumers, okay, are able to buy more computers. Without the trade, only 160 US citizens could buy a computer. 110 US citizens or US consumer couldn't afford computers because he went to the market and couldn't find computers. Okay, those 110 consumers, they couldn't find computers. With the trade, this 110 person or people who wants to buy a computer because they need it for their study, they need it for their work, they need it, etc. Now they could afford computers. So now they are happy or happier. Before they were sad, they couldn't find computers. They couldn't afford computers. Now they are happy because they can afford computers. So with the trade, more and more people, more and more consumers, more and more individuals in the US could afford trade. So we say that now more and more people are happier than before. And this is why I hope this explains why or demonstrate principle number 5 that says trade can make everyone better off. So the same thing for Japan, we can do the same work. Japan produces 200, I will not do the calculation, but you can do it at home. Please do it as exercise. Japan produces 240 computers, 0 wheat. It will import, doesn't import computers. It imports in 700 wheat. Export 110. In exchange for the import of 700 wheat, it exports 110 computers. So the consumption of Japan is 130 computers and 700 wheat. So you see, here is the red point is production, and the blue point is consumption. So the consumption is above the production possibility frontier. So we are consume more than we produce. So here the Japanese can't produce wheat, but they still can consume wheat, 700. So now those who couldn't buy wheat under autarky, now they are able to buy wheat under autarky. They are now the people, Japanese people who eat wheat now, consume wheat, are happier than before. So they are better off. Okay. And they are satisfied with 130 computers. It's enough for them. It satisfies all those who need computers in Japan. And so they export the remaining to the US. So here, let's say the gains of from trade. So for the US, in computers, consumption without trade is 250. Consumption with trade is 270. So the gains from trade is 20. Okay. Wheat, consumption without trade is 2,500. Consumption with trade is 2,700. So the gains of trade is 200 tons of wheat. The same for Japan. Consumption of computers without trade is 120. Consumption with trade is 130. So they gain 10 more computers. Consumption of wheat without trade is 600. Consumption of wheat with trade is 700. Okay, so they gain more, 100 more tons of wheat. So you see the quantities consumed for each country and for each good has increased. So consumers now they consume more and more. Consumers can afford the goods they couldn't afford under autarky. Okay, this makes the society as a whole happier than before, and this represents and this shows how trade can make everybody better. Okay, thank you for your attention and see you Friday. Goodbye.
Goodbye.